All right, in this video, we're going to quickly talk about atomic structure. And in order to do that, the very first thing we have to talk about is the subatomic particles that have been found in the atom. These are the ones that you primarily need to be familiar with. So there are three primary subatomic particles that have been found in the atom, and those are your protons, your neutrons, and your electrons. If you will remember, your protons are positively charged particles which are found inside the nucleus of the atom. They have a mass of about 1 AMU. Now, what's an AMU? Because atoms are so small, those subatomic particles are even smaller. So we had no unit that adequately described the size of those subatomic particles, and so we created the AMU, which stands for atomic mass unit, to talk about the size of these very small particles. Now, again, protons have a mass of 1 AMU. They're found inside the nucleus. In addition to finding protons there, you'll also find the neutrons inside the nucleus. Neutrons are non-charged particles, so they're not positive and they're not negative, but they're also found inside the nucleus. So the protons and the neutrons are held together inside the nucleus, and they both have a mass of about 1 AMU. Now, your electrons, on the other hand, electrons are negatively charged particles, and they actually have about the same amount of charge as the protons do. They have the same amount of charge, it's just in the opposite direction, which is why electrons get a negative charge. Your electrons are found outside of the nucleus, so they are orbiting the atom or orbiting the nucleus of the atom outside. So they're still part of the atom, they're just on the outside of that nucleus that holds your protons and your neutrons. Now, the mass of an electron is really, really small. So for all intents and purposes, we don't even include the mass of the electron in the mass of your atom. Now, the mass of your atom is known as your mass number. So how do we find the mass number? Well, we find the mass number by adding your proton number, and another name for your proton number is your atomic number. So on the periodic table, when you look at the different blocks, the number that is the whole number, that is your atomic number. The whole number that's the smallest whole number in that block, that is your atomic number. And what it tells you is how many protons that each one of the elements of that particular one have. Now, so to find your mass number, you have to add your proton number and you have to add your neutron number. Now, I do need to caution you that other number that's given on the periodic table is not the mass number. We will talk about how you find that other number in upcoming videos, but that number is not the mass number. So don't use that other number in the box to determine mass number. To find your mass number, you always add your protons and your neutrons. Or, alternatively, if you know your mass number and you know your proton number, then you can use those numbers to determine your number of neutrons. And all you have to do is your mass number minus your proton number, and that will give you the number of neutrons that you have in your element. And again, it could be an element or it could be an ion. So what does it mean to be an ion? Well, ions are just elements that don't have the same numbers of protons and electrons. Because again, as we said earlier, atoms always have a balanced number of protons and electrons. They have the same number of positive charges as they do negative charges. And so when they don't have the same number of positive charges and negative charges, they're no longer called atoms, they're actually called ions. Now, you can have two different kinds of ions. You can have an anion, where you have more electrons than you have protons, and because of that, since electrons are negatively charged, your ion will have a negative charge. Or you can have cations. And cations is a situation where you've got more protons than you have electrons. And because there are more protons, and protons have a positive charge, then your ion will also have a positive charge. Our elements on the periodic table, we don't always want to write out the name for those. So if you'll take a look at a periodic table, you'll see that most of the elements have abbreviations for them. And those abbreviations we call chemical symbols. Please remember, a chemical symbol is always a 1-letter or 2-letter abbreviation for an element. Now, the abbreviation may or may not come from the name of the element. For example, the element sodium, the symbol that represents sodium is Na. Now, in these 1-letter or 2-letter symbols, you've always got to remember that the first letter has to be capitalized in order for it to be a correctly written symbol. That first letter has to be capitalized, and the second letter, if it has one, has to be lowercase. Okay? So please make sure that you keep up with that. Now, our symbols, again, don't always come from the name of the atom, so you'll have to learn the symbols that actually don't come from the names of the atoms. You'll have to memorize those. You'll have to get them to become a part of your long-term memory. Now, the next thing that we need to talk about in this chapter is how to write isotopic notations. And there are actually 2 different ways to write isotopic notations. If you have the element name or the atomic number of the element, then you can write the first isotopic notation, where we use the element name at hyphen and the mass number. And again, it has to be the mass number for that particular isotope. For example, as I have on the board, if we considered the isotope carbon-12, that would be lowercase c in carbon, carbon-12. Or if we considered another isotope of carbon, we could use the example of carbon-14. Now, on your WebAssign homework, when you have this particular isotopic notation, on WebAssign, please make sure that you do not capitalize the element name. So you would write that again as carbon with a lowercase c, 12. Now, something else you could do though, you could use the atomic symbol for carbon, so you could just write capital C hyphen 12. All right, and it would count that as correct as well. Now, the other way that you can write an isotopic symbol is using this AZ notation. Please notice the A, which goes at the top, is the mass number. And you find that mass number just like we talked about a few minutes ago. You add the protons and the neutrons in order to find the mass number. That mass number has to always go at the top. The bottom number, your Z, that's going to be your atomic number. Now, sometimes when you're using isotopic notation, they may not include the Z value. Well, how do you determine the Z value if they don't show it? And the answer is you just go to the periodic table, you look for that particular element, and then you'll know what the atomic number is based off of what you see on the periodic table. Also, beside the A over the Z value, you'll notice that's where you include the atomic symbol for whatever element it is. And then in the upper right-hand corner, that's where you include the charge. So if it's an ion, that's where you show your 2+, your 3+, your 4 negative, your 3 negative, whatever that charge is, that's where you would show it at the top right. And then you can see on the board, I have an example. If we do 4/2 He with a 2+ charge, all that means is the mass of my helium atom is 4, the atomic number for the helium atom is 2, and that this particular ion has a 2+ charge, which means it has 2 more protons than it has electrons. So in that particular ion, you will see that there are 2 protons, there are also 2 neutrons, but in that particular ion, there are no electrons at all. That's how I got the 2+ charge. If you've got any questions on this, please let me know. Hope you all have a good afternoon, and we will continue to talk about how you determine atomic mass in the next video.